All right, good evening, AP students. This is the beginning of the video that I informed you all that I was going to make. So just as a general guide, I'll probably say this in the email that I send as well, but I'm going to narrate my thoughts on every one of the multiple choice. Free response, I think I'm going to go through and narrate where it's helpful, hopefully in a single video. However, was looking through the free response questions, and there are multiple videos for each question on YouTube who I think like these people probably are explaining it as well, if not better than me. So I may simply link those as well. Because the AP problems, the free response, there's in-depth people who do them every year, right? They release them every year. So people do them and talk about how to do them every year. All right, let's go over the first multiple choice question. So the first two questions, I will label this. Also, I used to have a tablet where I could narrate and write on it, but I not working right now, so I type everything on Desmos. Hopefully this is still helpful and you can use it. Now, first question. The function has the following properties indicated in the table below. Which of the following must be true? Okay, so this is my thought process. I see a bunch of continuity answer choices, right? So first thing that pops up in my head is about continuity. And there is a straight up mathematical definition for continuity, which pretty much explains everything I would need to know for this concept. So limit definition of continuity, I would write it right here. And this is my limit definition. The limit as x approaches c from the left, right, of a function. So as I approach from the left, it must be the same as my limit as I approach it from the right side. Oops. From the right side. And this must be the same as, so from the left side, you can envision from the left side must be equal to the same as from the right side. And in the middle of those two sides is a point, and it has to be equal to that point as well. So f of c. So I'm going to emphasize this as important because, I mean, at the end of the day, this is sort of all you need to know for continuity, right? Is this limit definition. On the AP exam, if you wrote this every time on the free response and just work from it for any continuity question, you will get the points because they know you know the true purest mathematical definition, right? So let's see, which one of these following must be true? Answer choice A, f is continuous at x equals 1. Well, if it's continuous, that means, again, I'm applying this. That means as x approaches 1 of f of x would have to be the same as x approaches 1 from the right would have to be equal to f of 1. And is this true? Well, as I approach 1 from the left, you can see I'm looking at my table. As I approach 1 here from the left, my value is -1. So this limit is -1. That equals my limit from the right. That turns out to be equal to 3. And my exact value is 3, right? And that's according to this table, right? So clearly this is not continuous because my limit from the left is going way down at -1, while my other two, my point and my right limit are at 3. So this is not continuous, not continuous. All right. And my thought process would be this. As I go through this table, I see that 1, 1, 1. That means all three are equal, right? Left, right, and the middle point are equal. So I would jump, my eyes would jump to this. I know that my limit as I approach 3 from the left is equal to my limit as I approach 3 from the right is equal to f of 3, right? And again, this is true because according to my table, the limit is 1 from the left is equal to 1 from the right is equal to the exact value of 1. So my final answer choice is going to be C. And let me see if I can draw this. Styles. My final answer choice is it's continuous at C. At x equals 3. Right. Hopefully that makes sense. All right. Cool. Now we're going to move on to question 2. Let f be the function f of x is equal to x divided by natural log of x squared. Which of the following conditions explains why f is not continuous at x equals 1? All right, so I need to show it's not continuous. Well, Again, everything is based off my pure mathematical definition of continuity. I can draw all my conclusions that I need off of this definition. So let's work from this. I'm expecting it to not be continuous. So something is off with this, right? So my limit as I approach 1 from the left has to be equal to my limit as I approach 1 from the right. It's equal to f of 1. Something should be off, right? Something is wrong here, right? Because it's not continuous. Cool, so let's see what's wrong. Well, my function is x divided by natural log of x squared. So let me just write that x divided by natural log of x squared. Right. F of 1, that's natural log of 1 squared. All right, so let's see what's off. Well, as I approach from the left, right? As I approach from the left, here's one way I could think about it. Let's say I have a calculator. I could choose a value from the left. So the way I did it, let's try 0.99 or even 0.999. 0.999, that's my value from the left. From the right, so let's see what my limit is approaching. Let's try 1.001, 1.001, 0.01. Finally, 1 divided by natural log of just 1 squared. This is exactly at 1. Okay, so let's see what's wrong. Well, from the left, it's negative 499, so it's probably going to negative infinity. All right. From the right, it's going to positive infinity because it's going to 500. And the exact value is literally undefined because this is a divide by zero error. Divide by zero error. So nothing is equal to each other. Everything is wrong. Nothing is equal to each other, basically, if I wanted to put that into words. So which answer choice does that match with? Well, let's look. Answer choice A, both limit as x approaches 1 of f of x and f of 1 exist. Well, okay, that's just not true because the limit doesn't exist because these two are not equal. And f of 1 doesn't exist, so it's not A. Limit as x approaches 1 exists. Wrong. Both the limit as x approaches 1 and f of 1 exist. That's wrong again. Neither the limit as x approaches 1 exists, nor f of 1 exists. Good. My limit doesn't exist because, again, these two are not equal. They have to be equal to each other. And it's undefined. So my answer choice is going to be D. Excellent. All right, let us continue. Question 3, suppose f is continuous on the closed interval 0 to 4. Okay, so I'm thinking continuity, right? Thinking continuity. And suppose f of 0 equals f of 1, f of 1 equals 2, f of 2 equals 0, blah, 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 blah. Which of the following statements about the zeros of f on 0 to 4 is always true? Ooh, f is exactly 1, 0 on 0 to 4, f is more than 1, 0. Okay, so I start off thinking continuity. But then I'm not asked about really if it's continuous or not. I'm proving certain values exist. Proving certain values exist using continuity. This should ring a bell. I mean, obviously we learned this before, so this is our refresher. But this is going to point us towards something called intermediate value theorem. And if we don't remember that, this is what it's saying, right? If my function is continuous, I can apply IVT, I can apply intermediate value theorem to show that certain y values are guaranteed. So, for example, I go from the y values of 1 to 2, right? So I know certain y values are guaranteed. Every value between 1 and 2 is guaranteed because my function is continuous. I cannot skip over anything between 1 and 2, right? So I have to show how many zeros there are. So let's label that, right? Okay, between 1 and 2, are there any zeros guaranteed? Not necessarily, right? No. How about between 2 and 0? Well, sort of, I'm at 0. 2, 0 to 3. So I cross 0 once. I'm going to put an arrow here. There's a 0 there. Then -3 to 3, there's going to be another 0 here. So I'm going to put another arrow here. So there's going to be a minimum of 2 zeros. A minimum of 2 zeros. Okay. Right, because I cross 0 at least 2 times. Now, which one of these answer choices says that? A, F has exactly 1 0. No, that's not. Definitely not. B, F has more than 1 0. Okay, this is sort of tricky, but it's actually going to be B. Because the statement more than 1 is the same as at least 2. Right? If there's more than 1 of something, there has to be at least 2 of them. Right? Some common trick answers are it's not C and it is not D. So my answer choice is B. Read carefully, more at least 2. So it's not going to be C or D. All right. I'm going to move on to question number 4. The function f is continuous. Okay, I'm thinking continuity. On the closed interval 1 to 3 and has the values that are given in the table below, the equation g of x must have at least 2 intersections with f in the interval 1 to 3 if k equals, okay, continuity. Again, I am proving certain values exist. I'm proving there's certain intersections, certain values exist, right? Certain values. Because if I prove there's intersections, I'm proving those values exist. Okay, proving certain values exist, which means I'm going to intermediate value theorem. All right. What am I trying to prove exist? Well, I'm trying to prove that g of x equals 1 has at least 2 intersections with f, right? So basically, f has to cross 1 at least 2 times. So f must equal 1 at least 2 times. Right, that's the whole point. If g of x is equal to 1 and f is intersecting with it, then f has to equal 1 at least 2 times. All right. Well, what value of 1, what value here would make f equal 1 at least 2 times? Well, let's think about that. F starts at 2 and goes to 3. If I chose a number like 4, let's say I chose 4. Well, let's imagine that. F starts at 2, so I'm going to write 2. It goes to 3. If this middle number here is 4, if k is 4, 4 is above here, 4, am I going to cross 1? Absolutely not, right? 1 is way down here. 1 is this line down here. I am not going to cross this value, right? I mean, I might, to be clear, but most likely not. Look, this is clearly not going to cross 1, right? So your eyes might jump to B. I might cross 1 if it's equal to 1, which makes sense, right? This would be equal to 1. Well, that's also not the case because I might touch 1 once and come back up, but that's only 1 time. I need to cross it twice. My answer choice is going to be A, 0, because 2 here is going to hit 0 and then come back up. It has to touch 1 twice. Once when it's going down right here, and once when it's coming up right here. Right? So my answer choice is going to be A, 0. All right. Let f be a continuous function such that f changes from increasing to decreasing and the graph of f changes from concave up to concave down. Which of the following is true about the midpoint Riemann sum approximation for the integral from 1 to 3 of f of x squared plus x dx using 4 subintervals of equal width? All right, so now we're jumping to the new stuff that we've learned, right? Riemann sums. Riemann sums. This is areas of rectangles. Cool. Let's think about this. So 4 subintervals, 4 rectangles. So I like to just start off the most basic. If I have 4 rectangles, I know my areas. My formula is going to be LW plus LW plus LW plus LW, right? Very straightforward. That's the area of 4 rectangles. All right. Now, I'm going from 1 to 3 using 4 rectangles. So if I'm going from 1 to 3, which is two units using 4 rectangles, each rectangle is going to be 0.5, and I can show that because I'm going to do 3 minus 1 divided into 4 rectangles. Each of my widths is going to be 0.5. So let me write that down here. It's going to be L 0.5 or 1/2. So L 1/2 plus L 1/2 plus L 1/2 plus L 1/2. All right, cool. Now I'm almost done. I just need to figure out my L values, right? Well, let's think about my L values. To find my lengths of the rectangles, I need to figure out the Y values of each of the rectangles, right? So let's say my function, I go from 1 to 3, right, into 4 rectangles. So each one is 0.5. So 1 to 1.5 to 2 to 2.5. And it is a midpoint Riemann sum. So my first rectangle goes from 1 to 1.5. How do I figure out how tall this rectangle is, though? I'm going to plug in my midpoint. My midpoint between 1 and 1.5 is 0.75. 75, sorry, I cannot write, but that is 0.75. So I need to figure out my height of the rectangle by plugging in my middle point into my function. So instead of L, it's going to be 0.75 when I plug it into my function. So it's going to be f of 0.75 squared plus 0.75 times 1/2. All right, times 1/2 plus the next rectangle, which would be the next midpoint, right? Between 1.5 and 2. So that would be f of, and hopefully you're able to sort of mentally calculate for the midpoint. The point between 1.5 and 2, that is going to be 2.25. 2.25. Yeah, 2.25 plus 2.25 times 1/2, right? Cool. Then I keep on going. F of the next midpoint would be between 2.5 and 3. So that's going to be oh, sorry, I think I skipped one. Sorry, 1.75. I skipped this rectangle right here. I skipped the second one. So that's 1.75. 1.75. My last rectangle is going to be 2.25 squared plus 2.25 times 1/2. Final rectangle is going to be 2.75 squared plus 2.75 times 1/2. Okay. So here's my midpoint, right? You can see how it's broken down. Each of the 1/2 is the W. Each of the lengths is figured out by plugging in my midpoint into my function to find the height or the length of the rectangle. All right, now what does this look similar to? This is going to look similar to either C or D. So I'm going to cross out A or B, right? I have the 1/2 factored out, sort of. So they took the 1/2 and factored it out. Then they say either the midpoint Riemann sum underestimates the area, or the midpoint Riemann sum does not have enough information. And if you remember our notes, simply midpoint Riemann sums, we just do not have enough information. There's no way to tell whether it's an under or overestimate. So my answer choice is going to be D. That's just sort of the rule we have to have memorized. All right, next question. The differentiable function r is increasing and the graph of r is concave down. All right, that's some useful information for whether it's an over or underestimation. Values of r of t at selected values are given in the table above. The trapezoidal sum, okay, is given to us. If it were me, I'd probably think, okay, my trapezoid formula was C plus D divided by 2 times my base. right? That's my equation for a single trapezoid. Anyway, all right. The trapezoidal sum is given here, all right, and approximates 1 to 13. Which of the following statements is true? And I'm going to read the answer choice really quickly. The trapezoidal sum is an underestimate because r is increasing. Trapezoidal sum is an overestimate. And a light bulb pops into my head, which is, wow, they don't even ask me for the actual answer. All they are asking me is whether it's an overestimate or an underestimate. So I don't need to do any calculations. I just need to read the problem and determine whether it's an overestimate or an underestimate, and I can pretty easily do that because we have a rule. First, my function is concave down, and the notes that we took said, very simply, if my function is concave down, my trapezoidal estimate is going to be an underestimate. That's just a rule. So concave down, I'll write that out, concave down. This indicates that trapezoidal will be an underestimate. Plain and simple, right? Now, if you ever forget this, you can very easily determine what's true or not because it's always going to hold true. So, for example, I drew a concave down graph here. You could just draw this if you forget and just draw a trapezoid. I'm going to draw a trapezoid between here and here, right? Trapezoidal estimate. And remember, a trapezoidal estimate means I take into account both endpoints rather than it being an LRAM left endpoint or RRAM right endpoint. It's both. So I'm going to use the heights for both of these to draw my trapezoid. I connect them with a straight line. And you can see my trapezoid, the area of this trapezoid is smaller, right? You see this gap right here, that gap, right? So anytime if you forget, you can just draw it, right? Same with the increasing or decreasing. These are obviously not the right answer choices, but for LRAM and RRAM, you could just draw it and see whether it's a overestimate or underestimate. So my answer choice is C. Okay, final multiple choice. The data for acceleration A of t of a car from 0 to 6 seconds are given in the table below. If the velocity at t is equals 0 is 11 feet per second, the approximate value of the velocity at t equals 6 computed using a left-hand Riemann sum with 3 subintervals of equal length is what? All right, so this one's sort of tricky. I actually wouldn't expect you all to know to get this right necessarily. Like, for example, if you put B or E, I'd be fine, right? Because this requires a little bit of conceptual understanding. First, I just gave it to you because the left-hand Riemann sum, they ask it pretty straightforward, right? Left-hand Riemann sum with 3 subintervals of equal length. So yeah, it's a pretty straightforward question. You would just calculate it, right? So LW plus LW plus LW. Equal length, yeah. So it looks like 0 to 2, 2 to 4, 4 to 6. It looks like the width of each of my rectangles is 2. All right. The length of each of my rectangles is based on the left-hand sum. So I'm going to go from 0 to 2. I look at my left side. Left side between 0 and 2 is 5. So it's 5 plus 2 plus my second rectangle, 2 to 4. My left-hand side is 2. So 2 times 2 plus from 4 to 6, my left-hand side is 8. So it's 8 times 2. All right, so it would be 30. However, I said to be sort of careful with this one. I wouldn't expect you all to get this because my velocity starts off at 11 feet per second. So my velocity it increases by 30, but it also starts off at 11. So my final answer choice is actually going to be E because 30 plus 11 is equal to 41. All right, hopefully that makes sense. All right, I'm going to pause it right here because this is it for the multiple choice. And yeah, so like I said at the beginning of the video, I'm going to take a look at the free response and probably link some better resources, if anything. All right, welcome everyone. So I'm going to discuss a little bit about the free response. I just unpaused the video, so that was probably like no time for you. But first thing I will say, looking at the free response, I think I mentioned this in class. Ignore part B of the first question. Just don't worry about it. Also, the last question, B, C, and B and C are both tough, but the one that you would actually need to ignore completely because you would have no idea how to solve it is part D. So ignore those two parts. Cool. Next, besides that, like I said, there are resources that answer these questions very in depth. I'm going to go through because I also cannot write out every step, like show my work written. So I'm going to sort of narrate in a way that might be helpful for some parts of these problems, but essentially I'm going to link some other videos to help with these free response problems. So first, looking at my first free response, I'm asked to estimate f prime of 4, right? So estimating f prime of 4, right, this is what I'm going to say. Actually, how should I type this out to know that we're talking about this? One moment. All right. Let me pause for 1 second. All right, addressing this, we are talking about part A. Right, so in the Desmos, what I'm going to say is this. Okay, we're estimating f prime of 4, right? Which is the derivative of 4, which is the slope at x equals 4, right? Estimating f prime of 4 is the slope at x equals 4. Well, how do I estimate the slope at x equals 4? Because notice I'm given a table. I'm not really given the function. I can't take a derivative. I don't know the slope at 4. However, I do know the points at 3 and 5. I do know the points at x equals 3 and x equals 5. So what I can do is I can do an average rate of change equation, average rate of change between x equals 3 and x equals 5. And this estimates the slope at 4 kind of well, right? Relatively. Because 4 is right between 3 and 5, so if I estimate the slope between 3 and 5, it probably estimates the slope at 4 sort of well. So part A, you would do the whole average rate of change is equal to f of b minus f of a over b minus a, except you plug in your values f of 5 minus f of 3 over 5 minus 3, right? Cool. So again, I'm just narrating these parts a little bit to help y'all, but like the concrete step-by-step where the person can write out all the work is probably going to be in the YouTube videos that I'm going to link. All right. Now, the other part I want to narrate is now I'm going to talk about part D. Part D is one so it's the toughest part of the problem. And it's all about, not all about, but it's more about intuition, seeing if you understand certain concepts, but it's tough. There's no like concrete steps to solve this. So first, they say use the line tangent to the graph of f at x equals 5 to show that f of 7 is less than or equal to 4. Use the secant line for the graph of f on f of 8 to show that the f of 7 is greater than 4 over 3. Okay, first thing, I need to figure out how to create tangent line and create secant line, right? Okay. First of all, equation for a line is going to follow my y minus y1 is equal to m times x minus x1. Straight up, it's going to follow this equation, right? Now, for my tangent line, let's say tangent, how do I find what's so special about this? Well, my tangent line at x equals 5, well, that's going to be my derivative, right? Derivative at 5, so f prime of 5, right? How about my secant line? How do I find that? Well, my secant line, secant is simply average rate of change. That's another way to think about it, right? My tangent is the instant rate of change. My secant is the average rate of change, right? So my secant line is going to be, the m is going to be actually the whole, again, f of b minus f of a over b minus a, right? That's my secant line equation. So I subbed in. Now I know how to find the slopes for both of those. Now, x1 and y1, these are just your points, right? So in this case, use a line tangent to the graph of f at x equals 5. So at x equals 5, one of my points is going to be, well, x is equal to 5, and y is equal to, well, according to my table, y is equal to -2. So y minus -2 is equal to f prime of 5 times x minus 5. All right. And what else do I notice? F prime of 5 is 3. They tell me that. F prime of 5 is 3. Cool. So I actually found my tangent line. Right? Okay. Now, this tells me a little bit, right? I found my tangent line, right? But what am I trying to show? Okay, they asked me to use my tangent line, which I found. So let's say I put a check mark here. I found it to show that f of 7 is less than or equal to 4. How the heck would I do that? Well, what do I know about my function? I know that my function, the second derivative is less than 0. So I know my function is concave down. It's going to look like this, right? My function is concave down. What else would I know? I would know that if it's concave down and I drew a tangent line, let's say it's a tangent line at 5. What do I notice? What do I notice? Concave down, my tangent line, sorry, I don't know why it's all caps. My tangent line is entirely above my function. Concave down, my tangent line is entirely above my function. You can see how this line is totally above the function. So f of 7 on my tangent line, you would have to plug this in to show. You could plug in 7. Plug in 7. But since it's concave down, f of 7 on my, sorry. Oh yeah, when I plug in 7, I'm going to get 4. So this is, how do I express this? My y value is 4. My f of 7 is down here. F of 7. Y is equal to 4 over here. I'm going to know my f of 7, since it's concave down, it's going to be below y equals 4, right? It's going to be below it because, again, my function is concave down. All right, hopefully that's confusing. I'm hoping, again, this is a tough problem, but I'm hoping the video can help clarify things. All right, let's move on. So this problem, I think, is very straightforward, actually. So I'm not going to really narrate much. I think the video should clarify that. This one is sort of similar. So the only thing I'm going to say, okay, I'm going to talk about part A. So part A, we are narrating about part A, where we talk about tangent line approximation, which we only spent a little bit of time on, linear approximation, right? All right. Tangent line approximation, I'm going to create my tangent line, right? And again, that's y minus y1 is equal to m times x minus x1. And if it's a tangent line, my slope is my derivative. That's just the definition of a tangent line. My m is going to be the exact derivative. It's the instantaneous rate of change. So it's f prime. The radius of the balloon when t equals, use the tangent line approximation at t equals 5. So f prime of 5, that's going to be my slope. Okay. Cool. Let's see, what else do I know? At f prime of 5, at 5, well, my x value is going to be 5. My y value at 5 is, do I know my y value? It's not going to be 2 because this is my derivative, right? So, oh, the radius of the balloon is 30 feet. So I think my y1 is going to be 30 when x equal to 5. And f prime of 5, that's my derivative. My derivative is actually 2, so I know it's 2. My slope is 2. There, I just created my tangent line. All right. Cool. Now, I created my tangent line, and let's see. So I'm going to use my tangent line to approximate my value. So use this tangent line to plug in 5.4, which will approximate my value. So I plug in 5.4, or I guess plug in x equals 5.4, which will approximate my value. All right, now, similar idea to the previous problem, right? What else do I know? I know the graph of my radius is concave down. So I approximate my value. Let's say this is my tangent line, and my function is concave downwards. I know my approximation, is going to be significantly greater than my actual value because it's concave down. If it was concave up, it would be the complete opposite. All right. Hopefully that makes sense. Sort of confusing, but yeah, think about a tangent line, how it relates to concavity. All right. Next thing that we're going to talk about is talking about part B. Part B, actually, there's not much to talk about. Part B is a related rates problem. Let's say related rates problem. All right, that is all I want to say about part B. Y'all learned how to do part B last week, so I think you should be able to take time to figure that out. All right. Last part that I want to talk about, talking about part C of the next problem. All right, part C. They told me that this function is used to define my velocity in miles per minute. According to this model, what is the acceleration of the plane at t equals 23? Well, how do I get from velocity to acceleration? Velocity. How do I do that? I go from velocity to acceleration by taking the derivative. So that's basically your hint is my acceleration, in this case, a of t, is going to be my derivative of this function. So I could write this as f prime of t. Acceleration is my derivative. Now, each of these, I will give you a hint. The rule would be a chain rule. And for a decimal answer, for an exact answer, you would use a calculator. All right, okay. So hopefully that's helpful a little bit. Again, if you want more detailed answers, I'm going to definitely link you to the certain YouTube videos. All right, thank you so much for watching. And yes, good luck on the quiz tomorrow. Bye, everyone.